So in this video I'm going to explain what object-oriented programming is, and we'll look at some real examples in Java. So far in this series of videos we've been looking at the syntax and structure of Java programs, but what really makes Java special is it's an object-oriented programming language. Let's have a look at what that means. So object-oriented programming came in the 1980s. Object-oriented programming is where we can structure our programs into objects. There's four elements of object-oriented programming which have to be present in order for it to be true object-oriented. That's encapsulation, inheritance, abstraction and polymorphism. Now we'll take a look at each one of these in turn. So encapsulation is where we take data and methods and package it into objects. Object types are defined in classes, and we restrict access to the data and methods. So we create a class which defines the object. We then put the data and the methods for that object into the class, and then we instantiate the objects later. So let's take a look at an example of how we might do this with a very simple example. We're going to build a very simple farm application, and it's a sort of database for animals on a farm. So we'll create an animal class, and that class has the name of the animal. So let's do that in Java. So I've got my farm class. I'm just going to write a main method. And that method's just going to create a new farm object. And when the farm object is constructed, we're just going to populate a list, an array of animals. So first I'll create my animal class. So an animal, it has a name, and that is a string. Now I'm going to make that private, and I'm going to make methods to get the name. When we construct the animal, I'm going to provide it with a name. So when we construct it, we'll set its name to be the name we provide in the constructor. And then I'm going to make a getter method so that we can get the animal's name, because the name is private, so we can't see that from outside the class because it's encapsulated in this class. I'm going to define a method, source, generate getters and setters, get name. Now I don't ever want an animal's name to change once it's been defined, so I'm not going to set a set name method. So we can be sure now that the name of that animal will never change, because there's no way of accessing it from outside of this animal class. So on the farm, I'm going to make some animals. Animal 1 equals new animal, and I have to give it a name. So I'll call this animal Colin. Animal 2, I'll call him Peter. Animal 3, I'll call it Sean. They're just three random names. And in this class, I'm going to have a private animal array animals. So animals 0 equals animal 1. And then I'm going to, for each animal in animals, I'm going to use a new for loop type. Where we can iterate over an array in this way. We say the class in the array is animal. So for animal in the animals array, we'll just system out print the animal name is plus animal dot get name. Okay, so we're expecting when we run this to see the animal's name is Colin, the animal's name is Peter, the animal's name is Sean. Run as Java application. So that's that. Okay, so the next thing in object-oriented programming is inheritance. So classes can have relationships with other classes. They can be parents or children. Now, in some languages, we can have multiple inheritance where a class can have two parent classes, but in Java, we can only have single inheritance. So one class can be a child to another class. So now we're going to take our animal class and we're going to make subclasses, child classes, and the classes are going to be cow, pig, and sheep. This, by the way, is UML, and this type of arrow in UML means that this is a child of this object. The three boxes in the UML class diagram, the top one tells us the class name, the next level down shows us the properties that that class contains, and the next level down tells us the methods. So now let's break our animal down into three subclasses: cow, pig, and sheep. So for each of cow, pig, and sheep, I'm going to say it extends animal. Now, because animal had a constructor with a name, we need to define the constructor in here as well. When we call super, we're just calling the parent class. And what I'm also going to do is I'm going to create a new package for these things, because farm is a distinctly different type of object to these others. So I'm going to create an animals package. And I'm just going to put all the animal types into the animals package. Now in our farm object, we're still going to have an array of animals, but the animals are going to be the different animal types. So Colin is a cow, Peter is a pig, and Sean is a sheep. We run the program, it's just going to do the same thing. But the type of class that these things are now is more specialized. So the next thing is abstraction. So we can define interfaces which aren't associated with the instance of the class. So there's two ways we can do that in Java. The first way is we have an abstract class. Now what an abstract class is it's a class which is designed to be the parent of other classes, but it in itself cannot exist as an instance. Now an animal is a good example of something that could be an abstract class, because we've got a cow, pig and sheep, but we don't want to just have an animal. So we can define the animal class now to be abstract, and then we can't create an instance of it, but we'll give it an abstract method, get species, and let's have a look at what happens when we do that. So we go into the animal class, we say public abstract class, and we can save that. Now nothing is going to go wrong yet, but if I were to try and create Sean as an animal, we've got a problem. We can't instantiate the type animal because it's abstract. So Sean is a sheep. The program's just going to do the same thing that it did so far, but now in animal I'm going to define a get species method, but I'm going to say public abstract. The return type is going to be a string, get species, and we'll save that. And now we've got an error on cow, pig and sheep, because what we're saying here is this abstract class animal, any classes that extend it or any child classes of the animal class have to define the method get species. So let's look at cow. We've got an error there. The type cow must implement the inherited abstract method animal get species. We can fix that error by clicking add unimplemented methods, and now we just need to write this. So get species will return cow, and I'll do the same for pig and sheep. So we'll add the unimplemented method and pig will return pig, and sheep will return sheep. And we'll adjust our system out print line so the animal's name is animal name, and we can use that method, and it is a plus animal get species. So let's see what happens now when we run this. The animal's name is Colin and it's a cow. The animal's name is Peter and it's a pig. The animal's name is Sean and it's a sheep. So that's what we wanted to happen. Now the other way we can do abstraction is to define an interface. What an interface is that any instances of a class that implement an interface must contain the methods defined in the interface. So here I'm going to make an interface called noisemaker, and that's going to have a method talk. And I could have the individual classes implement the interface, but I'm going to make the animal class implement the interface. It doesn't have to be an abstract class that implements the interface. Any class can implement the interface. So let's make our noisemaker interface. New interface, noise maker, and that's going to have a public method talk, and the animal class I'm now going to make it implement noisemaker, implements noisemaker. I'm going to save that. I just spelled noisemaker wrong. just correct that. Okay, now any class that implements the interface noisemaker now has to define the method talk, and we could have many methods here, but our noisemaker class just has a talk method. Now because animal is abstract, that does not need to define the method talk, but cow, pig and sheep now do. So like before with the abstract class, the abstract method, we can add it from the error talk, and here we're going to put the noise that the animal makes. Now this is quite funny because I know that animals make different noises in different languages, but in English cows generally say moo, and pigs, I think that they say oink. And I think that you spell it O-I-N-K. And sheep, or they say ba, ba. So now I'm going to make another loop through the animals method, but this time I'm going to treat the animal as a noisemaker for noisemaker animal in animals. I just need to Control Shift and O to import noisemaker. And now I can't access the getName method of the animal, and I can't access the species of the animal either, because I'm treating it as a noisemaker. So all I can do with it is things that a noisemaker can do, and that is talk. So the animal says animal.talk. So now we should loop through the old method and then loop through the talk methods. The animal's name is Colin and it's a cow. Peter is a pig. Sean is a sheep. The animal says moo, oink and bear. Of course we could still, because we know that animal implements the noisemaker, if the individual animals implemented a noisemaker, we wouldn't be able to do this, but because animal implements noisemaker, we can also do the talk method from here. And I just undo because I don't know what happened then. The animal says animal talk. So the animal's name is Colin and it's a cow. The animal says moo. The animal's name is Peter and it's a pig. The animal says oink. The animal's name is Sean and it's a sheep. The animal says bah. Okay, so we've been through encapsulation, inheritance and abstraction. The final one is polymorphism. Now we've already demonstrated that. So objects of different types are accessed through the same interface. So we did the abstraction via the abstract class, where we defined a method in the abstract class and then the method was implemented differently in each of the subclasses. We also did the interface, where the method was implemented differently in the subclasses. There's one more thing I'm going to show you, and that is object overriding. So if we go back to our animal class, I'm going to not make that an abstract class. So now it needs to define the getSpecies method. where we'll return unknown. And it also needs to define the method in noisemaker. And if we don't know what the animal's called, we'll just imagine that it says hello. So now we can instantiate animal. So on our farm, I'm going to add another animal to our list, and I'll make this 2, 3, and 4. Animal 1, I'm just going to call it, I'm going to call it Dave. And I'm going to add it to our list of animals. So now the animal's name is Dave and it's a cow. The animal says moo. I've accidentally created it as a cow. So now the animal's name is Dave and it is a unknown. The animal says hello, and back to the other three. Colin's a cow who says moo, Peter's a pig that says oink, and Sean is a sheep that says baa. Now the point of showing you this is that in animal we've defined the methods get, species and talk, but in the subclasses we've overridden them. And in the farm loop here, we're treating things as an animal, but when we call the methods, we're calling the methods of the subclass because that's what they are. Now I'm just going to add another method to our animal class, get description. And that's going to return name, the species. I'll call it get name. So that should return Colin the cow, Peter the pig, and Sean the sheep. Public string. I'm going to make the name and the species methods protected instead of public. So if we remember, private means we can't see the thing from outside of this class, and public means we can. What protected means is only subclasses can see these methods. So now farm, we can no longer see get name, get species. But what we can do now is get description. So now when we run this method, the animal's name is Dave the unknown, the animal says hello, Colin the cow says moo. So it's the same as before, but the thing is, by making those methods protected, I've made them private to the outside world but public to the inheriting classes. So subclasses can see the protected fields and methods of their parents, but classes from the outside can't see them. So that's what protected does. Now in this farm example, our animals are real world things, so it's easy to understand how we've taken the database of real things and created objects out of them. But objects don't have to be real world things, they can be more abstract things. So for example, an object might be a date, or it might be a list, or it might be some sort of processor. So you can structure your whole program around objects, but the easiest place to start is thinking of databases and things in a database and the relationship between the things. So maybe you might think of a bank has customers, a customer is a type of person, a person has a name, and you can structure object-oriented things like this. the more you do object-oriented programming, the more you get used to it, and it's a very useful feature to learn. One of the main points of it is that you don't want to be repeating code. You can encapsulate code which does a particular job in a class, and then you can reuse that class around. And you can also use some of the Java library classes or import other Java libraries to do things that somebody else has already done in your programs. So it's a very efficient way to design your programs, and it's very useful. So thanks for watching.